All right, does it say record there? You see record
Red?
red?
I saw a little red thing.
Yeah, little red flashing. Okay. All right, so this is geometry. And this is the first time we've gone through this. They worked on it this summer. I did not work on the design of this one, so I'm learning along with you. Okay? I have already done in the textbook the first 3 chapters and answered all the questions, so I'm familiar with where we're going, and that's going to be part of your responsibility, is that to be able to just pick up what is it that you're learning. Now, this textbook is different than almost any textbook of math that you've ever had, because you cannot jump to the back of the chapter and just do the answers, because the instruction occurs in the written part that leads up to the exercises. And so there's going to be a paragraph, and they're going to tell you something, then they're going to ask you a question, there's going to be a blank, and you have to fill in the answer. So you're going to basically talk to the book, and as you do that, you will learn and you will understand what the particular skill is they're trying to get you to. Okay? Now, I'm going to pull something else up here in a second because it's important that you see this. And so I'm going to try and see if to multitask this. Let's see. Geometry. All right, class per lesson plans to do. Okay, this is what it says. It is very important for students to understand that they should not know how to solve the problem yet. This first problem, you're not going to know how to solve it, probably. The start of each chapter, the presentation of the problem is the skills that you're going to learn in the chapter. So you're going to start, you're going to represent the problem, and then we're going to find out what skills are necessary to be able to find the answer to it. Okay? By the end of the central section, that's the text part, they'll learn how to solve it, right? And then this was to me, this says resist the urge to tell them how to do it at the beginning. Okay, so because of that, you are going to see some presentations and you're going to have some questions, which is normal, but I'm not going to give you the answer to the question because you're going to find it as you go through the text. Okay? All right, so this is what we're supposed to be doing, is that eventually you're going to do this. This is the first week assignment. That you're going to do pages 1 through 15. Now, what I did when I did this section, pages, just listen, it's not that hard. And pages 115, it took me 2 sides of the paper to answer the questions on the whole first 15 pages. So it's just every so often you're going to have an answer, right? And so you'll write the answer, and then you'll move ahead, and then you'll write the answer. Right? And so it's not that you're completing 15 pages worth of work. There's questions during the 15 pages. You'll see that as we get there. Okay? And then when you get to pages 17 to 19, that's like being at the end of the chapter. That's the questions and the exercises that go with the skills now that you've learned what the skill is. Okay? And now then there's also on the drive, you're going to have some other things that you can learn. In this particular, for here, you're going to go to Chapter 4 Extension for more proofs, and you're just going to read pages 1 and 2. That's all. Because that particular discussion goes with what we're doing in the first chapter. Right? And then it says stop at deductive reasoning, which is right at it's about an inch from the bottom of the second page. All right, so you're just reading the first part, you'll see that. And then you go into chapter 3, the PDF on notes, right? And you're going to read that. I think that's 3 pages long. That's just reading for reinforcement. And then the college algebra stuff we'll talk about in a minute. Okay? All right, and then as an assignment, you're going to watch the intro. That's him talking about chapter 2. Okay, now those are the assignments. The reason I'm doing this is that I have not had a chance to preview all of this. So I'm learning along with you what we have to do. Okay, so having said that, now let's look at this right here. Okay, now it says that this chapter is focused upon a famous problem. About 2,000 years ago, the solution involves several important geometric ideas from about points, lines, distances, and angles. Okay, this is all right. Now, a camper has a campsite, right here. There's a campsite. See where my cursor is? All right, and has a large flat clearing area that's right next to a straight river. All right, he is at a point that's 600 feet. Oh, he's over here. 600 feet from the water. So this distance from A to C is 600 feet. All right, and the camp is over here, 300 feet from the river. All right, he sees a large spark leap from the campfire, and it has set his tent on fire, aflame. Okay, the camper has to empty a pail already in his hand. Here, he has to run to the edge of the water, get a pail of water, and then run to the tent and put the fire out. And then the question is, what is the least amount of steps that he has to take, and where should he run to so that the distance from A to P back to B is the shortest? All right, that's the question. Okay, it involves geometry. Now, does anybody here immediately know the answer? Like, what's 2 times 2?
4.
4. Does anybody know a similar answer to this problem? Answer is no, you're not supposed to. That's what you're going to learn in chapter 1.
I'm going to guess it's the dotted path.
It is the dotted path, but where is that dotted path located is the question. Okay, and so, all right, now again, that deals with geometry. See, in geometry, all right, now, okay, what's the geometry that you've had in the past? All right, you've had angles, right? Have you had parallel lines?
Yes.
Cut by a transversal? Remember that? All right, so this point here, A, and this point here, B, are called vertical angles. Remember that? All right? And that this point A and this point D are in corresponding locations, so they are corresponding angles.
No angles are the same.
Right? And they're the same, they're congruent. Right? And because A and D are corresponding, and B and A are vertical, that means that alternating exterior angles B and D are also congruent. Okay? That's some of the things that you should have learned in 8th grade math. Okay? And so now, what does this look like compared to that? Do you see a difference? What's missing over here so that this looks like this? What's this? The other side of the river. It's the other side of the river, right? Okay. And so now, here's 2 parallel lines, and there's a transversal. But it's not one transversal. There's 2 of them. So that means we have something over here. Now, if I went from here to here to here to here, it takes too long. So what has to happen? I need to go from here to one point and then back over there. But where's that point supposed to be? That's the question from chapter 1.
In the middle?
Maybe. Maybe. Sounds good. What do you think? What do you think? Is middle a good place for it? But where's the middle located? See, that's another thing. All right, how would you know you were in the middle?
I don't know.
That's another geometry question. You see? And so what we have is we have a puzzle that we're going to have to begin to be able to figure out and learn some things from geometry. And when we're done learning the geometry skills and the geometry principles, we'll know exactly where that point's located and how to figure it out like that. Okay? So that's where we're headed. Okay? So let's take a look at the second page and see what it says. Okay, let's see. Let me try this.
So is this what it will look like? Is this like from?
Yes, this is the chapter. Okay. There, that's better, isn't it? Okay. Distance between 2 points. Okay. Now they're just telling us that A to C from that drawing. Where'd the drawing go? Oh, I see. You can make that bigger too. Let's go back on page 2. Yeah. Okay, yeah, that's better. Okay, so from A to C is 600, and from B to D is 300. That was given in the problem. All right, now. I've got to do this each time. Okay, so what does the drawing look like then? On your paper, make a drawing. It says make a scale drawing. Okay, now we don't have the materials right now for that, but if you had a ruler, you could use 1 centimeter is 100 feet, and so you could have a 6 centimeter and a 3 centimeter line. Would that be right? Okay, so you could draw a scale drawing. So right now, make a drawing that's similar to what you saw on that first page without me going back so that I don't have to redo that. So draw your river, and then over on the left, draw a point up top where he's 600 feet away. And then over on the right, come straight up and draw a point where the tent is, that's 300 feet, which should be about half the distance of the 600. Okay? Now, you could do that to scale if you were ready to. All right, so that's the first one. Now, using the scale drawing and a centimeter ruler, make the following measurements. So if you had that drawing, you could make the measurements for different places that you would come from the top down to the river and back over, and you could begin to measure the distances on several different places. Would you agree? Okay, so here's one right here. Here's an example. Is that you start at A, you go to some point that you pick P, and you go up to B, you measure the distances from A to P and from P to B, and then you measure the lines, angle 1 and angle 2, using a protractor. All right, does everybody know how to use a protractor? Anybody not ever used one? Okay, good. Then we don't have to learn that one. Okay, so when you're done doing that with several things, you're going to begin to discover something. Now, I'm not going to tell you what it is, because you remember that first thing says, I'm not supposed to tell you. All right, you're supposed to learn that. So that's the first thing that you're going to do. Okay, now, let's see if we go to the next page and what happens. Okay, so, all right, now, with your scale drawing, you're going to begin to fill those out. You're gonna, the distance from A to P and back to, and again, if 100 feet is 1 centimeter, then if you have 14 centimeters, that's 1,400 feet. All right, that's the reason for doing it to scale. All right, and then you're gonna do the angles, right? And you're going to begin to find out what happens here. And you notice that the first column says what? C to P. All right? And so that's the first thing that you have to find out. Is that where does that begin? Because this is, whoa, look at that. You see that one, couldn't you? So notice C to P's here. All right, so when this is 100, if you use 1 centimeter as 100 feet, then this would be 1 centimeter apart, and you would measure from A to P, and then from P to B, and then multiply it by 100 to get the number of feet. Okay, and then you would measure these two angles, and then you're going to move from the 100 all the way up to over here, whatever that was in the chart. Let's see if I can do this with the, yes, good. Look at that, isn't that good? Okay, so you're gonna work on those measurements. So what is this bottom measurement, 1,200 feet? What does that mean? That means from where directly coming down, from where that is all the way here, it would be 12 centimeters. Okay, 12 centimeters, about that long. Okay, all right. Now, so when you're done with that, then you're going to move to part 3. And it says, using the measurements in your table, it says, guess how P should be chosen in order to make A plus B as small as possible, where you're going to see the values here. All right? And you're looking for A plus B as small as possible. All right? And so when you start, what can you sort of predict is going to happen here? What should happen with these numbers? All right? It should start relatively large and then begin to go down until it reaches the minimum and then start going back up. Because what is it look like? It looks like in a parabola. All right? And in a parabola, right, the x squared and the negative x squared are the same values, right? And they all meet down at the vertex. Right? So if you think of it that way, that's the numbers that you're looking for, but these are going to be linear numbers instead of parabolas. And then, and it says compare your conclusions with a classmate. I don't think you're going to be able to do that if you're doing this at home. Okay? All right, now, so now we're moving on. And then it says, all right, we can say the distance from the point to the line. All right, now we're getting into something on this next page. It's talking about a definition. Now, in algebra, there's a word that's called altitude. Have you ever heard of that word before? All right, think of an airplane. What is the altitude?
Depends.
Depends. Well, no, what is an altitude?
Oh, the height.
It's the height, but it's the height straight up. So that means, what's the angle with the ground? Of an altitude. It's perpendicular, so the angle will measure 90 degrees, right? That's perpendicular. That's an altitude, right? Well, we're going to use a similar thing. When we talk about the distance from A to the line, we're talking about an altitude going perpendicular, going straight down to the line. Okay? Now, we're gonna agree that that's what's going to be distance. Because what would happen if I started here at A and I walked over here? That would be a distance to the line, right? But it wouldn't be the shortest distance to the line. All right? Kaylin, she was looking at her iPod. She ended up way over here. Right? So she says, it was 14 miles to that line from where I was standing. Right? Now, is she right? Yeah, the distance from A over to here could be 14 miles, but it's not going to be considered the shortest distance. And when we talk about distance, we're going to not use the word shortest. We're going to mean it, but not use it. Does that make sense? Hello? Does it make sense?
Yes, sir.
Okay, good. So now that's a learning process that, because I've already read this, that's what we're supposed to learn from there. Okay? And so now we come to here, and do you know what perpendicular lines are?
Yes.
All right. No, those are parallel. Perpendicular are T's. They're T's, all right? Okay, so if you understand perpendicular, that's not news. Okay. Now, imagine a point Q moving left to right on a straight line L. All right, the fixed point is A. All right, which angle do you think will be larger? Angle 1 or angle 2? Well, which angle is larger, angle 1 or angle 2? 1. Okay, now, which angle do you think is larger when Q is nearest to A? All right, so what's going to happen is, to get closer, I'm going to have to move it this way. And what's going to happen to those angles?
They're going to equal out.
They're going to eventually equal out. Okay? If Q is the point on L nearest, then what is the size of angle 1 and angle 2? Only one person knew the answer. All right? When Q is as close to A on line L as it can be, it's going to be directly under it. What will be the measure of the two angles?
90 degrees.
Everybody agree? All right, does it make sense? Okay. All right, now we've just learned something that's going to help. We've just learned something. If there was a way to get this perpendicular line, then we would be at the shortest position. All right? You have, with your ruler, you have a way to do that. With a protractor and a ruler, you can find that point. Okay? Now, complete the following statement. All right? That's what you're going to do, only we're not going to do that one because you're going to do that. Okay? Now, the next thing you go into is reflection. Now, tell me, how far is the ear away from the mirror if it's a reflection? The ear is the same distance from the mirror as it is from the reel. So if the reel is here and it's a true reflection, the distance from the ear to the mirror and the distance from the reflection ear to the mirror is the same. Okay, what did I just say?
The reflection from the reflected ear
Is the same distance from the
Okay, now, in 8th grade, when you talk about reflections, if I reflect across the x-axis, right? Let's say the point is 4, 7. Right? The x-axis is here, right? So if I'm reflecting across the x-axis, I'm up here at 4, 7, and I go down here. Which value is changing?
Y.
The y, because I need to know. The y value changes, the x value stays the same. So the reflection will be at 4, -7. Now, how far is this from the x-axis? It's 7 units. How far is this from the x-axis? It's 7 units because it's the absolute value of y. So one goes 7 down, the other goes 7 up, they're both 7 units. That's how reflections work. Now that's an 8th grade skill, reflections. right? But you probably didn't do that when you were in 8th grade, right? So you're missing that idea. So it just helps you with that. So therefore, what do you know about this distance and this distance? They're the same. Okay, now that's going to come into play back in that original problem. All right. Now, so suppose I'm here. Suppose that L is a straight line and B is on a point here. Okay. Then with the idea of mirror reflection, where can we get B star? How would we locate B star? All right, now stop and think about it. What do we have to do? All right, we want the shortest distance to the mirror. How do I find the shortest distance?
Straight line.
Straight line. So therefore, I want to come down here. All right, perpendicular. And then I want this distance here, if it's going to be B star, or sometimes they'd say B prime, right? Then this distance has to equal this distance. And it's reflected. Okay, now, when you look at that from a geometry standpoint, how do I make a line perpendicular to this line going through B? I have to put my protractor and have that 90-degree going through that point. So I'd have to slide this down a little bit so that the B point, and then wherever that lined up would be where on the line the perpendicular would be located. That make sense? All right, so this again, this is in geometry, because geometry is talking about protractor. Now, again, these two are what? 90 degrees. All right? Let's see if I can do this. Where is it located? Next week, I'm going to have an extension cord that I can get up to the board without tripping over. I've already tripped over and pulled this plug out twice today. So, okay, now, all right, look at the number 5. Draw a line L on your paper and mark a point B that's not on L. Okay, all right, so draw a line and draw point B. All right, now, how do you find B star or B prime?
Draw a line.
All right, now, you have to have a compass, not a compass, you have to have a protractor and a straight edge. So the first thing you're going to do is you're going to align from B and the line where B is going through the 90 degrees. All right, and then you're going to draw that line, and then you're going to measure from B to the line, and then duplicate the measurement on the other side of the line to make B prime. Does that make sense? Okay, so let's stop right there and let's discuss that. Because again, all of this should be new to you because you haven't done this type of geometry. Okay, so I have a line, let me do it over here. All right, I have a line, and I have a point right here. So I'm going to take my protractor, and I'm going to lay my protractor on the line, and this is going to go through the 90 degrees. When I do that, then right here I can make a dot that's on the line. Then I'm going to remove the protractor, and I'm going to measure from here to here. Now let's call that X. Now, what do? I extend this line out here, and I measure again, and let this be X, and that becomes the point for B prime. And to do it right, it takes that many steps in that order because we're doing it to scale. We're not just doing it freehand. Does that make sense? Not hard, but just new. It's different. Right? Okay? Make sense? Now, 6 says draw a line on a sheet of paper and mark a point N that's not on L. Now, find N, the reflection across L, using your ruler and protractor. That's what I just showed you. Right? Now, compare your method with those in the classroom. Well, you can't do that, so you only have one. All right, did you use conditions 1 and 2 in the definition of reflection? Now, what are they? 1 is perpendicular, and 2 is same distance. Same distance from A to the line as it is from A prime to the line. That's the two conditions. All right, now, if B prime is reflection across, then what is the reflection of B prime across L? Now, that's kind of weird. All right, okay, so let's say that I have a line here, and this is perpendicular. All right, that makes perpendicular. If this is A, and this is A prime, what is the reflection of A across L? What is its name?
A prime.
A prime. Okay. What is the reflection of A prime across L named?
A.
A. That's all I'm saying.
Oh, man.
A lot of words for that, but that's what it means. Okay. All right. So what's that tell you about A and A prime? They are reflections of each other. Right? Okay. Now, the next part is really important. Because now it says we're going to do this. We're going to take B and B prime, and then we're going to select a point over here. All right, so I'm going to do this right here. Is if I draw this, I know that this and this is the same, right? Because that's the definition of B and B prime. Then what do you think is going to happen? That's what you're going to find out. What do you think is going to happen to 1 and 2?
They're going to be the same.
They may be. We'll have to find out. And what about AP and what about BP and B prime P? They might be the same too, right? Well, that's what you're going to find out. And said if B prime is a reflection of B across L, then for any point P that's on the line, P to B, now, okay, now, it is equals, and if you put a line, a curvy line on top of it, that means congruent. Now, if it's straight measurement, it's equal, right? Because this is talking about the line, they're congruent. If you were to put those on top of each other, they would match point for point. So because this is not a value, you have to use congruent.
So that is.
It means equal.
But the sign you're saying is one line with a squiggle.
It's an equal with a square. See, let me explain it this way. This is the similar, this is for similar. Same shape, but not the same size. Like you could have two squares, but they're not congruent. One square is larger than the other. They are similar in design, but they're not exactly the same. Okay, so now watch what I'm going to do. I'm going to take this and put it on top of an equal sign. That's called congruent, same size and shape. Now, for the measurement standpoint, they're equal. But from a geometry standpoint, the shape is the same size and the same shape. Okay? Make sense? So that's, and again, if you put equal there, you would be sort of right, but congruent is the correct word. All right, now, choose a point P and measure A and B. So you're going to begin to see this. Okay, now, if B prime is a reflection of B, then for any point L, or P on line L, angle 1. Now, in this case, if we're talking about, if this said the measurement of angle 1, we would have equal here. But does it say measurement? Does it say measurement, Caitlin? Does that say M angle 1? No, so therefore we should say it's congruent. Okay? Now, that's a discovery that comes from this particular chapter. Okay? All right, and I've gone through that. 11, 12. What time do we stop? 20? 35. 40. Okay, good. Okay.
It's 11:30.
I think it's
So it's on the sheet out there, I think.
this is a lunch station.
Lunch starts at 11:40.
Lunch is 11:40. Yeah. We start at 30 and we end at
It's
40.
an hour and 10.
An hour and 10 minutes, yeah. So we start at 30 minutes. Okay.
It doesn't say on.
Okay, so now we have two triangles. All right, that was the end of this last one. Okay, so number 10. In the picture below, B prime is a reflection of B across L. Why is AP plus PB equal to AP plus PB prime? Because this value and this value are the same, right? So if I go from A to P, and then I go from P to either B or from P to B prime, I've traveled the same distance. So it doesn't matter whether I go down and up or I go down and over if I could do that. But guess what L is going to end up being when we're finished? L is going to end up being the riverbank. So see, now we're beginning to produce some geometry that's going to get us a condition. Now then, this is something new. This is something else. All right. If you have three lines that make up a triangle, what do you know about connecting any two of those together? All right. Think of it this way. If these are two lines of a triangle, in order to make a triangle, if I connect these at the top and I connect it to the bottom, what happens if the bottom is so long that it's out here? Is this a triangle? No. How come? Because it's open at the top, right? So if I have two sides that I added together, the other side has to be smaller or less than the two sides added together. Look at the red. AC has to be smaller than the other two sides added together. That is called the triangle inequality. All right, and so the longest side of a triangle has to be shorter than the two shorter sides added together, otherwise you won't have a triangle because it won't prop up to make a triangle. Okay? So AC has to be less than AB plus BC, where AC is the longest side. And of course, if it's not the longest side, then it's obviously going to work out. Okay, did you write that down? That would be a good thing to write down. All right, now. All right, in the picture below, A and B prime are on opposite sides of L. P is a point on L, and Q is the point where the straight line goes through. Okay, now this is the next part. All right, what they're saying is that there you see B prime. So where is B located? Where's B located?
Opposite.
On the opposite side of B prime. So how would you find it? Well, what I'd have to do is I'd have to use my protractor. Whoops. All right, and I'd have to set it up here so that this was at 90 degrees, and I'd want to draw this line, and then I would measure this from here to here, and measure it here, and that would become B. All right? So I'm just showing you this is what you have to mechanically do if I put my protractor in the right spot. All right? Now, what do I know about B to Q and B prime to Q? B to Q and B prime to Q.
They're gonna be the same.
They're the same, right? Okay. And so what they've done is they've drawn a line from B prime to A prime. And this angle is equal to that angle because those are vertical angles with the edge of the. Now, what do I know about this line? This angle is going to equal that angle. Okay. See how it's beginning to make sense? All right, now remember that original drawing? We started at A. He had to run to the water's edge, pick up a pail of water, and then run back to here. Now, why is AQ plus QB prime less than AP plus P to B prime? Why is this angle, this distance here, less than this distance here? Because these are two sides of a triangle. And going from here to here, over to here, if it's a triangle, these two have to be greater than going straight. Otherwise, you wouldn't have a triangle. Right? So unless you go from A straight to B prime, you are taking longer steps because the shortest distance between 2 points is a straight line. Okay? So, draw a line L and mark points A and B prime. Now, find the point P on line L, which makes AP plus BP the smallest. Okay, now, we just went over that, but what do you do if you're drawing it? You're taking a ruler and drawing the shortest distance between the two lines. You're drawing the line between here and here. Right? And so you draw the line between here and here. And wherever that point is, that's the point P. Then you know that this distance and this distance would get you B. This angle and that angle are the same. Again, this is all the learning process, and I'm going over this with you the first time, so that when you go back and actually do it, you'll begin to see all of this, and all of a sudden it should begin to make sense. Okay? Now, okay. Can't see it anymore. All right, this is talking about supplementary angles, which you should know about. Vertical angles, do you know about vertical angles? Vertical angles are equal, right?
Yes.
And so this is angle 1. That's going to become our sign or symbol for angle. So what does angle 1 plus angle 4 equal? It's a straight line, isn't it? How many degrees in a straight line?
90.
No, 90 is perpendicular. 90
180.
180 straight across. So what about 4 and 3? How many degrees between, if you add 4 and 3?
100.
180 both. Okay, now, find the other 3 angles. Okay, so if angle 1 is 30 degrees, how much is angle 3?
30 degrees.
30. And then what is 4 if 1 is 30?
150.
150, and 4 and 2 are the same, right? You should be able to do that given any of these measurements. Okay. Now, what I do, if I were doing this, I would say angle 1 is 110 degrees. How come? Why would I do that? It's not to scale, is it? But if angle 1 is 110, then angle 3 has to be 110, because they're vertical angles. All right? And if angle 3 is 110, then angle 4 is 70. Mathematically, not visually. You see that? Okay, and so to make this the hardest, I wouldn't put it to scale, because if angle 2 is 135, then what is angle 4? It has to be 135 because it's big just like angle 2, right? And so if the drawing is not to scale, some people that are just doing it by what they see will assign the wrong angles. That make sense? Okay. All right, now. Okay, so let me see, what do you notice angle 1 here? All right, what's it related to? It's related to angle 3, right? Because they're vertical angles across this straight line from A to B prime. And then we've already found that from this point Q, that B to Q and B prime to Q form 2 congruent angles as well. So if we know this value, we can construct angle 3 and angle 2 and know where B has to be located. The distance from Q to B prime is the same as the distance from Q to B, and so we can actually draw the scale based on what we've learned about these angles. Okay. Now, how do we find P? All right, this is the last thing. Okay, remember, here's B. Where's B prime located?
Opposite.
Huh?
Opposite.
Opposite side, right, a reflection across L. So I would come down here, and let's say that my cursor is where B prime is. Then I want to draw from my cursor to A, because that's where P needs to be. Remember the straight line that we drew? Right? That's the skill that they're trying to teach. Is that given these 2 points, I construct the perpendicular and reflect to B prime, then draw the straight line from B prime up to A, and that's going to put P in the right location. All right? All right, and that's what they're doing there. All right, now, that's the end of the chapter. This is the summary, and there's the problems. Okay. Now, I've gone through it relatively quickly, but what happens is as you answer each of the questions, on each of those pages, you'll begin to develop the understanding so that when you get to 15 through 17, I think is the exercises, you should be able to answer all of those based on what you did. Yes, sir.
So will the assignment, will that be on grade length on your teacher page?
It will be, yes.
Okay, good.
Yeah.
Because I did not write everything down.
Okay, so and if you'll notice now, look at here. This is review problems. And then projects we're not going to do unless you have to. And then there's algebra review. And and then there's answers. Isn't that nice? Okay. Now let me see if I can get to. Let's see. Here. I don't know if I'll put it up on teacher page or not, but let's find out. Loading. Come on, load.
It's weird. I thought they said they had fiber optics.
Yes, well, it was going much faster this morning.
Fiber is fast, for sure.
So that's switching.
Very nice. Fast.
All right. Okay, so amendment. Okay. All right, let's see if we can go over now. There's the main teacher page.
I didn't realize it exactly 4 months over Christmas.
Wow, then.
I know, like, honestly, we really don't have that.
There it goes.
I just realized.
Okay, I don't have it up there yet. I'll put it up here. All right, let's go to. All right, okay, so. All right, this is going to be the assignment that you're going to have. All right, you're going to do pages 1 through 15. Now, we've been over 1 through 4 or 1 through 12, I think. So we got almost to the end of this whole 15. So you're going to go back through it again, and you're going to write it out with a ruler and a protractor so that you do it to scale. And then you're going to complete the review section 1 to 11 all. That's the review. All right. Then you're going to read these pages, and I'll put that up. All right. This is on your drive. You're going to read those pages, and then you're going to read this page. And I think it's 2 pages here too. All right. And now, and then I'll also put this up. You're going to do the first 10 of these. And I already have those. I'll send you this email. It looks like this. All right, it's just 10 problems. Now, here's what's going on with these. When you take Math 133 in the spring, that's college math, college algebra. All right, the first thing, there are 78 pages of review of skills that you're supposed to know how to do. And it's really hard to do that over Christmas break. All right, so what they've done is they've incorporated those skills by, we're doing a few problems each week. So do these, work them out, and save it. Okay, now what I've done is I'm going to give you, I'll send you this as a file so that you don't have to go back into it. I've got the book, so it wasn't hard for me to do this. All right, but you don't have the 133 book yet, so I'll be sending you these.
Oh, so then like basically we'll already have it done for whatever we have to do.
Exactly, yes, yes, okay. And then if there's a problem that you can't figure out what the answers are, then we can talk about it. Most of these are just trying to be able to do it. Okay? All right, now we got 10 minutes left in class. All right, any questions about what we've done? Okay. This is a completely different type of math book, isn't it? Yeah, it really is. And I have seen back in the 1980s, I saw the preliminary that this book came from. And I used it in Hall County as a geometry book. And it's conceptually done well. It's just so different from here, memorize this, and then use it. And so I had not done this particular chapter before, but once I got started in the chapter, I saw how it related to some of the other ways to teach geometry. And so it'll be good. Hopefully you'll figure it out. If you have a question, you can email me. I'm going to try to answer it that way. I can't think of anything else. Do you have any questions? All right, so I will try to get this up on the teacher page by this afternoon. And I didn't get the whole package until yesterday. So I knew I had already been working on the book, but I didn't know about all the other stuff. So I don't know exactly how that all works out, but we'll figure it out. But anyway, so, all right, so now tell me something that you've learned in geometry that you've learned about what we've already done today. Okay, what is a reflection?
Opposite
Opposite of what you
like.
All right, okay, and how does it cross the line? Starts with a P. Perpendicular. All right, and what else do you know if it's a reflection?
It's the same distance.
Very good, say it loud.
Same distance.
It's the same distance from B to the line as it is from the line to B prime. Okay, all right, and then if there's another point on the line that's not on the line from B to B prime, then what do you know about going from B to the point and then back to B prime?
The distance is the same.
The distance is also the same, right? And then what that's eventually going to do, have you ever heard of the triangle congruence called side, side, side? Okay, we're going to eventually find, so if the distance from B to the line is the same as from the line to B prime, and the distance from B to P is the same as B prime, and the distance from B to the intersection is the same because it's the same point, then you have side, 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 and the two triangles are congruent. They're exactly the same size. And that is one of the triangle congruence formulas, is if each side is congruent to another side, then the two triangles are congruent. All right, and again, those are things that build off of what we're working on right now. See, because right now we're just trying to be able to find how to get from A to P back to B in the shortest distance. All right, but all those things are going to build. And back in 300 BC, there's a guy named Pythagoras. Have you ever heard of Pythagorean Theorem? And they didn't have a whole lot to do, and he had wealthy support, and so he just worked on all these different math problems and began to figure out these relationships. All right, and one of the things that he found was that the area of the square of the two short sides added together was the same as the area of the hypotenuse, the square that uses the hypotenuse for a side, and that's where we get a squared plus b squared equals c squared. Well, he did a whole lot more, and he found all these different types of relationships because that's all he had to do. He was a math guru, and somebody else paid his living expenses for him to do that. So that's pretty cool. And there were lots of math people in the, oh gosh, all the way from the BC time up into the 15 and 1600s. Have you ever heard of like Mozart and Beethoven? All right, how come they spent all their time writing music?
They were bored.
No, because somebody else was paying their living expenses and they were the musician for that particular kingdom. And if they could get stuff published and other people playing it, then the king who paid their expenses or the baron that paid their expenses, they got bragging rights. Because my orchestra leader has had stuff published that everybody loves, right? And so back in history, there was a lot of people that had the ability to just dive into things and go really deep because they had other people paying their expenses. Okay? All right. Anything else? Then it's 38. I'm going to turn this off and we will be done. All right, Chase. Good luck, Chase.